is equal to what? Is equal to mass of the satellite times mass of the S times gravitational constant, then say negative 1 over 2r over negative over 2r minus 1 over radius of the S. Right? Radius of the S. So this is positive according to what? So I just copied this formula at this point. Next, we have to add. We have to know add the fraction there, which is subtractions. So to add the fraction there, it's simple for A-level student. So mass is mass of the S, gravitational constant, and then here we have denominator, which is what? Is equal to 2 radius times radius of the S. That's the denominator. So take this over this, you get negative radius of the S, and then this over this over this, you get 2r, so plus twice r. So this is the formula. So then now we continue. Change in total energy between point A and point B. For this case now, it will be what? We might say that it will be twice mass of the S times G divided by what? Times R divided by what? By twice R, then radius of the S. Hence we say what? Minus what? Minus mass of the satellite mass of the SG, radius of the S, of what? Twice radius of the S. So what I've just take this product of constant, I multiply with this one, that's what I wrote here. And then I took this one, I multiply by this one, that's what I wrote here in numerator. So then we can simplify them if you're interested. So such as this and this. And then so you can cancel this and this, you can cancel this and this. So you see, you might have what you had there. So change in energy, or in total energy, is equal to mass of the S times inverse of gravitational constant. And then we say that, yeah, so that's what we had there. So 1 over RE minus 1 over 2R. Okay, so if that's the case now, the next step, we say that, okay, are we given the value of gravitational constant? Universal gravitational constant? No. What are we given? The value of what? Acceleration due to the gravity, which is 10 meters per second square. So we are not given, this is the final formula, but we are not given what? The value of universal gravitational constant in the question. Also in this question, we are not given the mass of the S, so that is not the suitable formula. We are not given the mass of the S. What are we given? I have summarized in the data given. We have been given the radius R, the radius of the S, and acceleration gravity, and the mass of 40 of the satellite, which is 1,000 kilograms. So let us enjoy the beauty of 40 of physics, right? How? So this is the case. So now we were in 7th step. Now we are going to the 8th step. So the 8th step, you have to recall what I taught you in previous lectures of gravitation. That you recall the relationship, because we are not given. Make sure that you use the constant which you have been given. If any constant is not given, it's better to leave its symbol or its later there, rather than say that I know the value of this constant. So if the constant is not given, think again outside the box. How can you solve the problem? So this is the subscript, E subscript. Remember that relationship between what? Between universal gravitational constant and acceleration due to the gravity G. What did we say? I told you that the products of mass of the S times gravitational constant is equal to acceleration gravity times radius of the S. So for our case right now, the radius of the S is RE squared. Okay. So this was the second equation. So suppose that this is the third equation. So this is what? The third equation. And this is what? The fourth equation. So if that's the case now, we can take the fourth equations, substitute. So that the ninth step. Ninth step we say that substitute equation 4 into equation 3. Okay. So then if you substitute it, we get to it. The formula of change of total energy between 2 points on the S surface and on the satellite's orbit will be equal to the mass, then acceleration, gravity, radius of the S square. Okay? You may use either this formula or you may use this formula. Any of the formula will give you a response. You prefer, so let us prefer this one. So then we have what? And I think the best one is this. So the question 3, because these questions and these questions are similar, this is equation 3. So this is equation 3. I don't have a space there, right? So the equation 3, inside the bracket you have radius of the S, then plus what twice of radius of the satellite's orbit, over twice times radius of 40 of the S. Now we continue to enjoy the beauty of physics. Physics is beautiful, my beloved student. Okay, so we say that change in total energy is equal to what? So for that case, is there a negative? No, negative. 2, so there we have 2, okay, fine. So this is equal to what? So let me copy it. Change in total energy between the 2 points is equal to mass of the satellite times acceleration, gravity, radius of the S square, and then in bracket we have negative radius of the S, and then plus what? Twice radius of the orbit of what? Over twice radius times radius of the S. So what happens? So radius of the S, one radius of the S, and one radius of the S will cancel, right? So you say that change in total energy between the 2 points is equal to mass of the satellites which we are given, times what? Times acceleration, gravity G we are given, radius of the S also we are given, minus what? Radius of the S we are given, radius of the orbit we are given, and then we say what? Over twice R. So this is the final formula to solve our problem. So we go to the 10th step. So 10th step, we say that now let us compute the total, the total energy, okay, the total energy required by the body, the total energy of 40 of the body, total potential or gravitational, the total gravitational energy, the total gravitational energy. Now we can compute it according to the constant that you've been given, not according to the constant that you know. Use the constant that you've been given. So according to the questions, the acceleration gravity will be given as 10, not 9.10, not 9.8, don't cram. And then the radius of the S is 6,400 kilometer. So this is exponent 3 meter. And then we multiply by what? Negative 6,400 exponent what? Exponent 3 meter plus what twice. What the radius of the orbit will be given? 7,000 kilometer. So times 7,000 kilometer, 7,000 kilometer, exponent 30, exponent 3, to change it into meters. And then we divide this what? Twice, times 7,000 kilometer, which we change into meter. So this is the expression. So meter cancel, then remain short. This is meter per second, so we begin with this is Newton per kilogram. Acceleration, is it Newton? Acceleration? Yes, Newton per kilogram. So this is Newton per kilogram. So if Newton per kilogram, So you have Newton meter per kilogram. Do you have any other kilogram? Yes. We have to multiply with what? Mass of the earth. So I forgot some constant. So let me write clearly. So I might not leave any constant. Okay, change in energy is equal to what? It begins the mass of the satellite. 1,000 kilogram, sorry, not kilometer. 1,000 what? Kilogram. Excuse me. Acceleration gravity, we have been given 10 meter per second square or 10 Newton per kilogram. Understand that? 10 Newton per kilogram. And then so we multiply with what? We multiply with the radius of the earth, which is 6.4 exponent 6 in other words. And then so we multiply with what you have in the bracket, which is negative 60.4 exponent 6 meter plus what? Plus twice times what? 7 exponent 3 meter, and then the denominator that we have is what? Is twice times what? 7,000 exponent 23 meter. So I told you that this meter cancel, kilogram and kilogram will cancel. So it means is what? Newton meter, because this is meter. So unit of this radius of the earth is meter. So you have Newton meter, and Newton meter means what? Joules. Physics is beautiful. Then now it's a matter of using your scientific calculator accurately to find the change or the total energy. So the total energy, we say that if you do your computation there and everything goes right, total energy is 3.474 exponent 10 joules, right? And why is like that once? Because the mass of the satellite is exponent 9. Is it? This man is not sure. It's not tough to do that computation. So you just take 2 times 7 exponent 6. Yes. 6. Hence minus 6.4 exponent 6. Then divided by 2 or by 2 times 7 exponent 6. Then we multiply by 6.4 exponent 6. We multiply by 1,000. Multiply by 10. Response is 3.474 exponent 10 Newton meter. Yes, that's the right answer. So the change in energy is 3.47, and then so you can add another 4 in 3 decimal places if you like, exponent 30, exponent 10 Newton meter. So according to the questions, we are calculating what? The total. You have to respect the advanced physics. The total energy of the body, or the total energy of the satellite, total energy of the satellite is 3.474 exponent 10, a lot amount of energy. Joules. So that's the total energy. I do remember, or I think that you still remember when we have introduced you something about energy, it says a unity, during the O-level. And then you saw that, this is stuff very simple. Yeah, we are building the foundation. So now we have to build the house. Okay, so that's how gravitational mechanics is beautiful. It's one of the challenging topic of mechanics, but it is beautiful. So then, before I end this lecture, it's better if I give you the overview of how the final exam, or we call it advanced certificate secondary education exams, are being asked. So this will be your homework. I want just to show you the format, the form of the 10 of the questions of the 10 marks regarding the gravitational mechanics. But make sure that you have this book so you can solve many questions of gravitation, and you have the textbooks also in order to solve problems. So this will be example what? This was example what? 19? 17. Was it 18? 18? Yes, 17. So this is example 18. If I confuse the numbering, you can correct me. Don't worry about that. So example 18, we say that refer advanced certificate secondary education, abbreviations is refer. Before 2010, gravitation was one of the topic he contributed to one question in paper 2 of 20 marks. Then after amendments of, or after design, or after formulating a new syllabus, then gravitation now became one of the topic contributing in advanced certificate secondary examinations, physics paper 1, physics 1. And then the year, I would like just to say that let us solve the NECTA of 2016. It was question number 6, maybe question number 5 or 6. So let us write it for you to try many questions and test yourself. I insist you to have this review book, as I told you in the beginnings. It is a very good reference book. So make sure that you have this review book in order for you to solve many problems of 40 of gravitational mechanics. So in this year, they asked the questions of gravitational mechanics as question number 6, and it has 3 Romans, Roman A to Roman B and Roman C. So that's the reference, means that is the referencing. And in case of review, you find this question in page, I want to give you too much details, so to encourage you to go through these books. So the questions consist different parts, it means testing the world concepts of gravitation. So let us start with question number 6A. Okay. The questions say that Roman 1. Total marks is 10. Remember that. So it asks mention 1 applications of parking orbit. I told you mention 1 application. 1 applications of 40 of parking orbit. You might find that we have been given 1 marks. To mention, just to mention. How many applications I have told you about parking orbit? When we say about parking orbit, we are talking about artificial satellites. I told you 6 applications of artificial satellites, but the basic, the fundamental functions or applications of the parking orbit. This is a suitable orbit to place communication satellites. That's the primary goal. That's why we are learning for. I told you that if you pursue programs in telecommunication engineering or electronics engineering, you will enjoy the beauty of satellite communication. So this is simple. So just review the notes. Then you have question number 6. B. No, yes, B or A, still A. Roman 2. The question says that briefly explain how parking orbit of the satellite is achieved. Briefly explain how parking orbit of the satellite is achieved. I told you. Means that how do we place satellites in the parking orbit? So I told you the procedures. Firstly, what the first procedure, the satellite has to be taken by the rocket into the desired orbit. Secondly, the satellite should be given the initial velocity we call the orbital velocity, right? Thirdly, the height of the orbit, of the parking orbit should not be greater than, it should be equal to 36,000 kilometers. So you have many conditions and you know how. Okay, so that is all about the, so you might find that maybe this one will be given 2 marks. So question number 6B, right? Question number 6B, it also has 1 Roman. The S satellite revolving, the S satellite revolves. The satellite revolves in a circular orbit. In a circular orbit. A circular orbit at a height of 40, the height of 3,000 kilometers above the Earth's surface. Above the Earth's surface. So you have 2 questions. Find the Roman 1 velocity of the satellite. Velocity of the satellite might be given 2 marks. And then the period, find the period of the satellite. This one will be given 2 marks. So total now, if you manage to solve the whole questions up to part A and B, you have 7 marks. So how many marks are you going for 10? 3. So how about this question? This is very simple, I told you. Why I told you? I told you the general formula of finding the orbital velocity of the satellite. We derived, that's what you have to use here, and even we did 1 problem on finding the orbital velocity. If you have orbital velocity, you can determine period. How do you determine period? Period is equal to the circumference of the orbit of our orbital velocity. So the answer of part 1 will be the input in the OT, or will be the denominator of the formula 40 of part 2. So the orbital velocity, do you remember this formula, orbital velocity? Orbital velocity is equal to what? Radius of the S, square root of what? G of what? Radius of the S. Then depends, radius of the S plus what plus H. So this is, so the issue is this 3 kilometers above the S surface or from the S surface? Read the question carefully. The Earth satellite revolves in circular orbit at the height of 300 kilometers above the Earth's surface. This is the height H. It's not R like in previous question. Because that one is from the S, not above the S. That's why it was 7,000 kilometers. 7,000 kilometers is greater than 6,400 kilometers. So this one is less than what is 6,400 kilometers. So because it's less, this is the height above. What I mean that I told you, suppose that this is the Earth's surface, and then this is the orbit. So here we have radius of the S, RE, and then we have RE, right? And then here we have what? So at this point, we have also the height. So the height is equal to 300 kilometers. We make a difference, differentiate it with R, which is from the center of the Earth to the orbit of the satellite. I'm helping you. So because I want to give you and assist you to be confident whether your computations is right or is wrong, I would like to give you responses, answers, the final answers of Roman 1 and Roman 2. So you can check yourself if you are right or you're not right. So it is question number 6. 41. 41, the orbit of velocity will be the orbit of velocity will be 77.21.28 meter per second, which is almost 80,000. You remember that we found is 80,000 meter per second, or 80 kilometer per second. You remember that? Yeah, so you have to differentiate with the one that we found 30 kilometer per second. And then the period of revolution, period T, you have to make sure that you get 1.5 hours. 1.5 hours. Then part B of this question, B of these questions also so question 6 C part 1. Why are space rockets rockets usually launched from west to east? You know that I told you this answer. This is one of the conditions of placing the satellites in the parking orbit. For the geostationary satellites, we say that they should revolve or they should orbit the Earth's surface from west to east. Why? In order to have the same period of revolutions with the Earth's rotations about its own axis. So that's the explanations testing you about what I told you. So you have the material to answer that question. Then Roman 2, a spaceship. So with this one, you might find that it's 1 max. So he said that a spaceship is launched. Okay, it's launched into a circular orbit close to the Earth's surface. Close to the Earth's surface. Close to the Earth's surface. What additional velocity So remember that this is your homework 10. Homework 10. With the goodness of this homework 10, I give you the answers. Please follow the principles. Follow the principles. Use the accurate formulas. Don't forge. Because if you give students answers, they used to do maneuvers, not to get the required response. So, to the Earth's surface, what additional velocity What additional velocity has to be imparted has to be imparted to the spaceship in order to overcome gravitational pull. In order to overcome gravitational pull. So find additional velocity. Find what is additional velocity. What the meanings of additional velocity? Additional velocity. Read the questions and understand what does it ask. A spaceship is launched into a circular orbit close to the Earth's surface. First of all, what does it mean? When I say close to the Earth's surface, it means that the radius of the orbit will be equal to the radius of the Earth. That's the meaning. Then, what additional velocity? So it's orbiting around the Earth's surface. What additional velocity has to be imparted to the spaceship in order to overcome gravitational pull? What does it mean? The question's asking about escape velocity. Because escape velocity is a minimum initial velocity that required by a body to be removed completely from the gravitational or the Earth's gravitational pull. So, didn't I teach you escape velocity? I taught you. So let me give you the response, however that you know, because we calculated it. So the answer of this question is what? The additional velocity, or let's say additional velocity, is the one that we have already determined. 7,926.3 meters per second. So these questions you might be given 2 marks. What are the constants that you need? The constant here, we say that you need gravitational constant 6.67. These are givens at the top of your question paper, which is Newton meter square kilogram square. Also, you need mass of the S is equal to 6 exponent 24 kilogram. And also, you need radius of the S. Is radius of the S given? Is there any points that will be given radius of the S? There? So radius of the S is 64. So radius of the S is what? 6,400 kilometers. Okay, 100 kilometers. So this is 6,400 kilometers. So those are the constants that you need. So in this case now, you see how the questions of 10 marks being formulated, right? And then you see the build rate now of physics. It's not difficult because this covers, or it's just, for example, these questions, or these questions is just testing you from the concepts of what is satellites. It's all about the satellites. The questions is talking about all the satellites, spaceships, and etc. Sometimes the questions might talk or might ask you or might test your understandings concerning about gravitational energy. Sometimes maybe acceleration gravity. Sometimes the question might test you concerning on what maybe escape velocity itself, or maybe the Newton's universal gravitational law, or maybe Kepler's what first, second, and what and third law. So this is the all and the beauty of what of gravitational mechanics, according to the syllabus of we call it advanced syllabus for secondary, which we call the advanced physics syllabus for secondary, for advanced secondary schools in Form 5 to Form 6 in United Republic of Tanzania. This is more than what its recommendations have to teach you. However, that in part of the subtopics, I didn't teach some of the subtopics because I told you that the syllabus does not recommend, but in some, for example, if you go through these review books, you'll find a number of the questions which testing your understanding on the concept of 40, on the concept of variations of acceleration gravity due to the positions where it is, whether inside the S or on the SE surface or above the SE surface. So I might make a lecture of that, I know all the contents, but it's better for you first of all to cover all of these and put them in your mind. So this is the end of lecture 10, and I would like just to say that this is the end of gravitational mechanics. I thank God who have been with me on preparing all of this material. Really, it wasn't a business, a simple business, it was tough business, but God always is faithful, and God is always with me. So it also helped me to be committed on teaching you all of these lectures. So I thank God for being with me, and I thank God for yourself for choosing to learn gravitational mechanics with me. It's not, I know it's not an easy task. I will be still praying for you to understand what I've taught, because this material will be at your hands for the rest of your advanced life or ordinary diploma life. So I would like to say also, I thank you. In case that you didn't subscribe, subscribe, because this is not the end. We have also some other mechanics topics that which are on the way. We have projectile, we have learned about simple harmonic, so they are still on the way. So make sure you subscribe and you share this material with your colleagues, also your schoolmates, with your young brothers, with your elder brothers, and tell us also in the comment sections you are enjoying the beauty of physics from which regions of United Republic of Tanzania, or from which country, or from which continent, or from which city. So tell us in the comment sections, tell us about your district, and even the schools. We'll be happy to know that we reached the place where you are. And this is the beauty of digital technology, and also the beauty of internet. Okay, so join me in the other lectures of the other topics of physics. Thank you very much. I'm Sir Olenjolai Tayelo Single from United Republic of Tanzania, who is using different techniques and different aids, teaching aids, on teaching students advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics. Thank you very much for being with me. Stay tuned. Don't hesitate yourself. Join me in the next lectures. See you again inside.